Today's lesson is going to focus on acid nomenclature. And there are two types of acids that you need to be aware of and know how to name. One is called binary and the other is called oxyacids. So how are you to recognize an acid? Well, you learned about acids back in grade 10 chemistry, but we'll just remind you that all acids start with a hydrogen ion. So you're going to see that your chemical formula begins with a hydrogen. Whenever you see a compound beginning with a hydrogen, you are going to name it as an acid. They still behave as ionic compounds. Here's an example of where hydrogen is placed over on that group 1 metal side because it behaves like a metal, and here it does. So what we do is we follow ionic rules, which means we apply the crisscross rule, and we reduce if necessary, which will never happen because hydrogen has a charge of 1. And as we mentioned already, there's two kinds. There's binary acids, and then there are oxyacids. Let's look at binary acids first. The word binary means two. So when we are talking about acids that are binary, what it means is that they contain one hydrogen and one other single element. Okay, so you're going to notice a total of two different elements in your acid formula. We're going to use the crisscross rule to develop the formula because they are acting as ionic compounds. And then when we name, we always do the same thing. We use the prefix hydro. We then state the name of the other element. And sometimes we chop off some letters. Sometimes we don't. Again, it's kind of like practice to get you to know which, when do you do that, when don't you? And then we also add a suffix of ic acid. So let's look at a couple of examples. Here's hydrobromic acid. So we know that this is an acid compound. The name is listed there. And when we see that we're starting with hydro, we know we have hydrogen, who has a charge of +1. And bromic is referring to bromine, who also has a charge of -1. We apply the crisscross rule, and we end up with a chemical formula of HBr. Then we have hydronitric acid. So again, hydro is just simply telling us that we have a hydrogen, and charges on the hydrogen is +1. Nitric is telling us that we have a nitrogen, and nitrogen's common charge is -3. We apply the crisscross rule, and we end up with a chemical formula of H3N. And notice we only have two elements here. We always have hydrogen. We have one other type of element, usually a nonmetal. Sometimes it could be a metalloid. Here is a formula, so H2Te. So this is binary, right? Hydrogen, and then tellurium is the other element. And so the naming is always the same. We're going to call this hydro, and then we're going to state the name. So tellurium, we're going to take off a few letters. We're going to call it telluric acid, hydrotelluric acid. And then the last one is the most common binary acid. Everybody knows it. We have hydrogen, we have chlorine. We use the naming system of hydro, and then we call it chloric acid. The other type of acids are called oxyacids. And as the name suggests, you're going to have a hydrogen start off your chemical formula. And then you are going to have a polyatomic ion with your hydrogen that is going to contain an oxygen atom. Okay, so it's always going to be a polyatomic. It's always going to contain an oxygen in it. We're going to continue to use the crisscross rule, but now the naming for it is slightly different. We do not use the term hydro. Hydro is meant for binaries. Here, all we do is whatever polyatomic ion we are going to use, we state the name of it, and we know that those polyatomics either have suffixes of ate or ite. So we replace those suffixes with either ic acid or us acid. Okay, so if you notice that the polyatomic is sulfate, you're going to call it sulfuric acid. If you know that it's sulfite, you're going to call it sulfurous acid. Okay, so here are some examples that we're going to go over. So H2CO3. So right away you can tell that this is an oxyacid. We've got a polyatomic ion and we have oxygens. So all you care about is this right here. What is the name of CO3? So off you go, you look it up, you see it's carbonate. So we're going to replace ate with ic acid. We're going to call this carbonic acid. Next door, we have HBRO. So again, you are only focused on the BRO ion. And what is the name of it? And that is called hypobromite. So all we're going to do is replace the ite with us acid. So we call it by its name, which is hypobromous acid. Down below, we have sulfurous acid. So we know if it's OUS, that the ending would have been an ite. So we know that this would be sulfite ion. And we look up the sulfite ion. And the sulfite ion is SO3 with a charge of -2. We apply the crisscross rule, and we come up with a chemical formula of H2SO3. The last one is perchloric acid. So we know that the ic acid came from an ate ion. So it would be perchlorate is the name of the polyatomic ion. You go look up the perchlorate ion, which is ClO4 with a -1. You crisscross it with hydrogen, and so you end up with HClO4. So one of the tricks to oxyacids is that not all polyatomic ions are listed on every chart or every periodic table. And you don't need all of them. There are 4 different versions of polyatomic ions that follow a predictable pattern and a predictable set of names. So on your periodic table that you use, you only have 2 sets that list all 4 different versions of a polyatomic ion set, and that would be the chlorine and bromine polyatomic ions. If you look at those, you'll see all 4 versions of those ions that are listed there. Other than that, at least one version, 1 or 2 versions might be listed on your periodic table. But once you understand the pattern that sets itself up, you'll be able to determine the name and formula for any other polyatomic ion not listed. So there are 4 versions, and the second version right here, let me get my pen going here for you. This version right here is what we call the standard radical. Okay, so it's kind of a weird name, but they claim that these 4 different versions of polyatomic ions are called oxyacid radicals. So you find whichever one ends in ATE and has no prefix. Okay, so notice that this might apply to chlorate or carbonate, or over here it is right here, sulfate. And what we do is once we know that that standard radical, what it is, if we add an extra oxygen, we still maintain that ate suffix, but we put the prefix per before it. So if you look over here for the example I've given you, persulfate has an extra oxygen at SO5, and they maintain all of the same charges. Okay, so all of the charges are exactly the same. If we have 1 less oxygen from the radical, okay, so the standard radical, we would take 1 oxygen away from the formula and we would give it the name ite. So you see that right here, that from SO4, if we go down to SO3, we call it sulfite. And then if we take away 1 more oxygen off of that standard radical, so 2 oxygens away from sulfate, let's say, we still maintain the ITE suffix, but we call it hypo. And again, charges stay the same for all of them. So you have a worksheet in your booklet where you can practice these oxyacid radicals and get comfortable to the 4 different versions of them. But once you know this pattern, you'll be able to determine the name and chemical formula of any radical in any polyatomic series.